So today we're going to be discussing what we call the definite integral. We have seen how we can approximate the area under a curve using a Riemann sum. Today we're going to discuss in a little more depth what we consider to be the definite integral. So just to remind you, if I have some given function, f of x, g of x, whatever the case may be, the definite integral so that's a picture scenario of the situation. Our definite integral looks like this. The integral from a to b of f of x dx, okay? And we're going to start to call a our lower bound and b our upper bound. So if you hear me use those words, that's all I'm referring to is the a and b in the definite integral. And this is really just math notation for the area bounded by a curve, the x-axis on some interval ab. Okay, so our definite integral is going to have a bunch of properties, and you're going to find these really easy to work with. Okay. Most of them are just common sense. The integral from a to a of f of x dx is 0. So if I don't move, I don't have any area. The integral from b to a of f of x equals the negation of a to b. So this is important. Our integral always has to be set up from the lower bound to the upper bound. So if we're evaluating a definite integral in the opposite order, we have to negate, okay? And we're going to do plenty of examples to help you understand that. The integral from a to b of f of x dx equals a to c plus c to b. All this means is we can break up an integral if we need to. Okay? If our functions are different and if we're dealing with different situations, we can break it up and evaluate separately. The integral from a to b of f of x plus or minus g of x, again, all this means is we can separate definite integrals if we need to. Sometimes we might have an algebraic function and a trig function. Okay, so these are things we're going to work on and introduce this year so we can kind of develop them more for next year. And lastly, this is my favorite rule, the integral from a to b of c times f of x dx means you can always move any multiplier out front if you need to. Okay, and this one we tend to use a lot. All right, so let's just jump into some examples because this is really a very, very easy topic. Use the graph to find each value. So I have the graph of some function. The areas are given to me. Now be careful because this is below the x-axis. It's really -10. So we have to be aware of that when we're dealing with the work. So I want to find the area under the curve from a to b of f of x dx. So I'm talking about this area, which is just 12. The area under the curve from b to c. So b to c. And again, remember, the number is 10 here, but because it's below the x-axis, we're going to have -10. The integral, or the area under the curve from c to b. Now in number order, look at what's happening here. This is reversed. So I need to rewrite this and rearrange and put my lower bound. And when I do that, I negate the integral. So now I'm going to negate whatever I got from b to c, which was -10, and my overall answer will be 10. And lastly, from b to d. So now I have two pieces, two separate pieces. I'm going to show you how you would write this in the proper notation. However, I know you can do this in your head. The first piece is b to c. And then we would go from c to d. So this is an example of property 3 up here, where we can separate when we need to. And now b to c is -10. The integral from c to d is 8. So our overall area is -2. Okay. So that's a nice, easy example to start with using your properties. The numbers, the values are given to you. Sometimes you'll have to do a little more. Okay? So in this case, I'm giving you a graph. Okay, our function f of x is made up of lines and a quarter circle. Okay, So now we need to read the problem, determine the area we're trying to find, and now since all of these are geometric shapes, we're going to use geometry to find the areas. So this first part A, I want to find the area under the curve from 0 to 2 of the given function. So I look at the graph, 0 to 2. I see that my graph is a quarter of a circle. Right? I want to find that area under my graph. So basically, I'm going to remember that the area of a circle is pi r squared, and I'm going to divide that by 4. Pi, the radius of this circle is 2, so I have 4 pi over 4. So the overall area for this piece here is pi units. In my next example, part B, I want to evaluate the integral from -2 to 2 of f of x. Okay. So now when I go up to my picture, I'm going from -2 along the x-axis to 2. So I see I really, right, if we were going to break this up, let's talk about what's going on here. -2 to 2. I actually have, if I look, I have a trapezoid, a rectangle, and a quarter of a circle. So if I was using math notation, I could break this up from -2 to -1 of f of x dx. Then the next piece is going to be -1 to 0 of f of x dx. And then the next piece is the integral from 0 to 2 of f of x dx. Okay. So now all I have to do is go back up top here and calculate each of these areas individually and then add them up. So this is a trapezoid. So a trapezoid, h over 2. So I have 1 over 2, base 1, which is 1 unit, base 2, which is 2 units. So the area of this section here is going to be 3/2. The area from -1 to 0. So if I'm looking at this area here, that's just a plain old rectangle, so it's going to be base times height. That area is 2. And we already did this area. That's not going to change, and that area is pi. So if I look, I have 3/2 plus 4 halves. The overall area here is going to be 7 over 2 plus pi. And you're going to see that a lot of times we're just going to leave our answers in terms of pi just like that. Okay, always try to add the number part together. Now we're going to go back up top here, and we want to calculate the integral from, what is our example here? 2 to 6. Again, I have 2 pieces. I've got this triangle here. Now you could break it up into 2, but I think I'm just going to leave it as 1. So I have the integral from 2 to 5 of f of x dx, plus, then I'm going to have this piece from 5 to 6 of f of x dx. And both of these are geometric shapes, so we can easily calculate the area of each section individually. So this is going to be 1/2. My base is 3 units. My height is 2 units. 6 over 2, this is going to be 3. And the area here, again, another triangle, 1/2 base times height. This area is 1. Now remember, when we go to put it into our formula down here, the integral from 2 to 5 is 3, but because it's below the x-axis, it's going to take out a negative area. So -3 plus 1, our overall area there is going to be -2. And lastly, this one should be pretty easy because we have most of our sections worked out now. The last example is from 6 to 0. Okay. Now again, the lower number always has to be, this is one of our properties, the lower number always has to be on the bottom. So since I'm flipping the numbers, I have to negate my integral. And I'm going to kind of cheat a little bit now because I think we're pretty comfortable with what's going on here. But basically, we're going to negate whatever we get from evaluating the integral from 0 to 6. So if I look up at my picture, going from 0 to 6, I have pi minus 3 plus 1. Pi minus 3 plus 1. This is going to be pi minus 2. Distribute your negative, and you get 2 minus pi as the overall answer. So just a little bit of work with definite integrals. They're actually kind of fun. This is one of my favorite topics in calculus. Okay. So now I don't have a picture. I just need to be able to apply my properties. No big deal. Okay, so we're going to think back. So I have the integral from 0 to 7 of 2 times f of x. So I'm told what the integral from 0 to 5 of f of x is. I'm told what the integral from 0 to 7 of f of x is. And to evaluate this now, I just apply my properties. This guy here is what we call a multiplier. Again, my favorite property. We're going to bring that guy out front. And now we can see we can make the replacement. So this is 2. The value they give me for the integral from 0 to 7 is negative 10. And your overall answer is negative 20. See how nice and easy that is? It's almost kind of fun. Not really fun, but kind of fun. The integral from 5 to 7. Okay, so I know what 0 to 5 is. I know what 0 to 7 is. If I just want to get 5 to 7, think about this like a number line here. So I know what 0 to 5 is. I know what 0 to 7 is. If I just want to get 5 to 7, I'm going to take the integral from 0 to 7 of f of x dx, and I will subtract out the integral from 0 to 5. These are how these properties work and help us. So I have the integral from 0 to 7 is negative 10, minus the integral from 0 to 5 is 3. So my overall answer using the properties of definite integrals is negative 13. Part C of this question. Now I want to go from 5 to 0. So remember, when we're dealing with a definite integral, we have to go from the lower bound, the lower number, to the upper number. So if I have to rewrite, I have to negate. The integral from 0 to 5 is just 3, so our overall answer is negative 3. And our last example now, so I have the integral from 7 to 0 of 6 times f of x. Remember, we have 2 things going on now. I've got to reverse, right? I've got to flip my bounds, and I have a multiplier. So I'm going to take, since I'm flipping my bounds, I'm going to negate it. I'm going to bring out my multiplier, rewrite my integral in the proper order, and now I can substitute my known values. So this will be negative 6. The integral from 0 to 7 is given, and it's negative 10. And you do a little math, and there's your overall answer. So I hope you see that even though calculus may look a little bit scary, it's really, there's a lot of topics in it that are quite easy and kind of fun to do. So now that we worked through a few examples together, I think I may just read through this and let you guys kind of work on this one on your own. Evaluate the following definite integral. Hint, make a sketch of the piecewise function, and it should help you know what to do. So my definite integral is from 0 to 4 of f of x dx, where f of x is a piecewise function. And these are your 2 pieces. So if you give that a little sketch and you look at the picture, it should help you know what to do. So you can kind of pause the video for a little bit, work on it, and when you get the answer, you can check back to see if you got it right. I will put the answer key up. Have a great day, and tomorrow we're going to kind of tie all of this together.